Thank you, everyone. Yeah, so I'll be talking about graph database and retrieval-augmented generation. So I'm basically going to be just talking a little bit about RAG itself, ordinary RAG, and how you can actually do RAG with graph database. And what are the benefits, what are the limitations of RAG currently? And yeah, we'll just go through a simple tutorial on a notebook. I'll just run through it. So if there's any point where there is questions, you could just raise up your hand and I'll be happy to take them. Thank you. So yeah, RAG. How does RAG work at the moment? Basically, a user takes in, once you have a particular set of documents, probably chunk the documents, feed it into an LLM, and you chunk the documents, you embed the documents, and you put it inside a vector database, right? And afterwards, when a user asks a question, you get the user query, you embed the user query, convert it to vector embeddings. You could use various embeddings out there, OpenAI embeddings or Mistral or whatever kind of embeddings that you want to use, actually. And then you save that in your vector database. And once the user makes a query, you do the vector, you present it in the vector representation. Then you use that vector representation to search your vector database to find similar kind of document to answer that particular question. And when you find that similar document to answer that particular question, you take those documents as context for the LLM, and you just pass that to the LLM with the initial user query. Then you send it to something like OpenAI or Claude or any large language model provider that you want to use. And then it's going to return that particular, it's going to return the response to you in normal human readable format. And we are going to be going through that also as well today. So what is the limitation with ordinary RAG at the moment? Like I mentioned before, before you store your data into your vector database, you are going to chunk the data because one of the reasons why you actually need to chunk the data, breaking it down into smaller pieces, is because you need your embedding models will probably not be able to embed 30,000 tokens of data, right? So you need to chunk that data that you have into smaller bits, and then you now embed those. You now do the vector representation, and then save it into your vector database. So popular vector databases that are used today for just normal RAG, you could use Qdrant, Weave8, Pinecone. In fact, you could use Redis, Postgres also as well. But today I'm going to be talking about using graph database and what the benefit is in using a graph database. So in this next slide, it's similar to the original RAG, right? But there is something different. Okay, so let me just take a step back. What are the limitations? Let me just go and quickly talk about the limitations. Sometimes when you do retrieval-augmented generation, ordinary retrieval-augmented generation, you might be missing some content, right? So for example, you might be talking about what happened in the 20th century in relation to what happened in the 17th century. But because you've chunked your data in various formats, you've lost that kind of connection in your original text, right? So I might be asking a question about, okay, how did this event in the 20th century relate to the 17th century? But it might not be, my RAG cannot be able to just link that particular, to those two particular set of events together, right? Because it might just retrieve 5 documents or something from the vector database relating to the initial query that I have, right? And which leads me to my next point also, missing top-to-rank documents, because RAG also, as much as the science, is an art, because you have to do like a lot of prompt engineering. You have to experiment with what your K values are, and by K values I mean what are the top number of content documents you want to get back, right? And also, at the moment, RAG also brings, like, you can just get approximated values from RAGs, right? And those are some of the problems that we are just going to try to solve with graph database today. And when I'm talking about RAG, I think it makes sense to talk about why we actually need RAG in the first place, right? So why do we need retrieval-augmented generation? Our LLMs as it is today, right? Yes, they are powerfully trained, but for example, your internal company's data, the LLM doesn't have understanding of that, right? But you want to be able to build a model where at least I can be able to, you want to build a system where I can be able to at least ask some questions about my internal data and I'll still be able to get very accurate response from that, right? For example, you might want to build a customer service chatbot, something like that, and you want to use your internal data to perform all these kind of operations. You don't want to train up your own LLMs based off of your own data, right? And another thing this retrieval-augmented generation would help avoid is hallucination. We know large language models today, they like to hallucinate a lot, right? So they can come up with answers on the fly, and they are not factually correct, right? But you want to be able to create something based off of the data that I have, can be able to give you factually correct information from your company's database, from your company's internal database or something like that. And yeah, so let me digress. Let me now go back to graph database. So the difference basically between the ordinary RAG and graph database is just the fact that you are giving more contextual data to the LLM. And that's just what is here, adding more contextual data based off of the relationship. So I remember the previous example I gave about an event in 20th century, how it relates to an event in the 17th century. Say you have a graph database, right? You build a knowledge graph out of that. Then you can be able to see the relationship about, oh, this is the question I asked. Initially, what we do is just go and look for the vector representation of that and returns the result to you, right? But now, with graph database, you get the vector representation, then you can add your own retrieval query as well, right? So I have this node. Now, I want to see how this node relates to other nodes around it. And that way, you can be able to fetch more contextual data for the LLM to be able to provide more factual information for you. So without further ado, I would want us to just dive into the code and just try to build a simple graph-based RAG today. So for what you'll be needing like an OpenAI key, Docker, and yeah, just your notebook. And I'm just going to, you can clone the repo here if you want to follow through so that we can just, get started. So just to give a brief overview of what we are going to be doing today. This is PyData conference, right? So what I did is we are going to get the list of all the speakers using the PyData API key and all the submissions. And also at some point, we are going to scrape through the PyData's website to get information about the conference itself. And then we are going to build a RAG system that can be able to answer questions based off of that for us. Like say, for example, what talk or tutorial is happening at Minorities at 11:30 a.m. today, right? You build a graph RAG system that will be able to answer that question for you. So let's jump into the code. So you can clone the repo from here, from this URL, and Okay. So the first thing we want to do is, once you've cloned the repo, there's a Docker compose file here. And I'm just going to enlarge this again. So this Docker compose file would help you install Neo4j. I'm going to be using Neo4j as the graph database for today. And we are installing various plugins, the Epoch plugins and the GenAI plugins. And you can just run, to run that you can, sorry, just a moment. Let me exit from this view onto my terminal. Uh-oh. Okay, yeah. So on my terminal, I'm going to run docker compose -d build. Uh-oh.
Sorry, sir. Do we need to create a .env before?
Sorry?
Do we need to create a .env file before?
No, the Docker file is available in the, in the...
The .env file?
It's .env.example.
Oh, okay, .m, yeah, just .m does example, yeah.
And what's the PyData API key?
I think if you sign into your PyData account, you'll be able to see like the API key underneath it, yeah. Yeah, Docker, you run docker compose up -d, then --build. Then this should start building the Neo4j the Neo4j image for you on Docker. Once that is built, then you can just go into your browser and yeah, localhost 747. And yeah, this is my Neo4j browser. Let me increase this a little bit. Yeah. So without further ado, I wouldn't want to assume that a lot of people are familiar with graph database, so we'll just go through some few examples of graph database itself so that we can just all move along. So if you go to the repo, there is a introduction to graphdb.md. And we are just going to run some few queries there. So there are various concepts in graph database. Let me just increase this a little bit. So there are various concepts in graph database, such as a node. A node is like an entity in the graph. Then we also have like a relationship, how one node relates with another node, right? And we also have properties. Properties are attributes or data associated with a particular node. So in a person node, you could have something like the name, the age, the country, and whatsoever stuff you want to put in the node. Then the relationship could be, say, something like person A is a friend to person B, right? Or you can say person A employs person B. You can define the relationship in whichever way you want to define the relationship. So now that I have my my graph database running, what I'm going to do, I'm going to come here and run my query. So I want to create a person node with attributes name, age, and city. So I'm going to run this, and it tells me I've added a particular label. And when I come to this side, I'm going to see my node labels here already. Then I can create another person as well.
Can you enlarge that?
Oh, this other one? Oh, okay. Can it go higher than this? I'm not sure. I'm not sure you can go higher than this. But if you clone the repo, you'll be able to see this there. I don't think this can be just a minute. Yeah, it can't go higher than this. Yeah, I tried Control Plus. Okay, let me just zoom. Okay, yeah, this is better. Is this okay? Okay, let me try opening it in VS Code and see. Yeah. Yep. Is this better? Okay. Okay, now we've created, let me just move this around. We've created a person named Alice. Now let's create another person named Bob. And yeah, we've created another entity and we can visualize our graph here. But at the moment, there is no relationship between Bob and Alice, right? So now we can create a relationship between Alice and Bob. So to do that, we can just run this query here. Now we've created a relationship between Alice and Bob, and let's visualize this relationship. So yeah, Alice is a friend of Bob, and on this relationship here, you could see you could add attributes also, like since 2020, right? So you could also do various things like create another person entity and say something like maybe James. Alice works for James, right? So you can now ask questions like, how is James related to Bob, right? So James is a friend of Alice who works for, Bob is a friend of Alice who works for James. So you could see how everything relates with one another just by visualizing this graph. Let's just do, so for, you could actually do something like matching nodes also as well. And when you run this, you're trying to get a person named Alice. You run this query and you're just going to get the result here. You're going to get the Alice node, and you can view like the properties here as well. Like the age is 30, city London, name is Alice, right? Then let's just do maybe some more slightly advanced query. Just slightly. Yeah, so let's run this. So yeah, when we run this, we are saying person A is a friend of person B, right? Where the name of person A is Alice, then return to me the name of person B, right? We are going to see that the name of person B here is Bob. And if you just go through this, okay, sorry. If we just go through this notebook here, this markdown file here, we'll be able to see various ways we could interact with the graph database, queries that we could run, and so many other things. So I don't want us to spend so much time on this, and let's just get into creating the graph rag itself. So yeah, let me move back to PyCharm. So like I said earlier, I'm just going to explain the structure of the file first. Let me just do that with VS Code, so since that's clearer. We have our Docker Compose file here, which we've run already. We have this notebook that I'll be working with, the graph database and RAG. This is the notebook I'm going to be working with. And you might want to install dependencies like LangChain OpenAI, LangChain Experimental, and so many other dependencies here. So you might just want to run that by running poetry install, and yeah, you get that all the dependencies on your local. So like I said, we are going to be picking up all the speakers and the submissions for this conference. And also later we are going to be scraping the PyData websites for more information. So we have dataloader.py. And from here, what we are basically doing is we are making a request to this endpoint, this PyData base URL endpoint, to fetch all the submissions that various speakers have made, and that they are going to be speaking at in this conference. So I created a Pydantic class called the speaker class, and we have the submission info class. In the speaker class, we have the name, the biography, and the ID of the submission. And in the submission info class, we have the ID, the speaker as well, and we have the title, the submission type, abstract, state, and so many other information like the duration of the talk or tutorial, the location, the date, the start time, and the end time. Then another Pydantic schema basically just for the submission results, a list of submission info. Then we also have another Pydantic class. This is basically for scraping the website. We have the title, the URL, and the content. So now to scrape to get the information of all the submissions for PyData conference this year, we are going to put in the base URL, the submission, and we are going to get our PyData API key from the settings file. We have the config file here, which loads all your environment variables. And then we are going to make a GET request. You are going to pass in your API key as an header, and going to make a GET request. Then you're going to be able to fetch all the requests. Then what we do is we extract the time and date. We pass the time and date to different formats. We have the date part and the time part. And now once we get the results, we'll pass the result into the Pydantic class itself. So for all the results we get the speakers, and we pass that into the speaker Pydantic class here, and into the submission info here as well. This is just basically some preparatory step we are doing for what we are going to do, loading our data into the graph database, right? Then I'm not talking about scraping the website yet. When we need to scrape the website, I'll go back to it. Then we fetch the data. Now we want to load our data into the database, right? So now I have, this is where the core of the function is. For all the results that I get from the API call to PyData, I'm passing everything to the submission, and I'm looping through all the individual submission itself. So what I'm doing here now is, if there are 3 speakers tied to one submission, I'm breaking them out into individual submissions itself. So let's just put that at the back of our mind. So now we are going to start creating the various nodes here. So the first thing I'm going to do here now, I'm going to first create my speaker node. And here I'm using merge. Merge means basically either create this speaker node with this attribute. If it exists before, just kind of do some sort of update. So that's what I'm doing here, merge. Then my speaker node here, then the ID of the speaker name, and the biography. Then I pass in all these parameters to it itself. Also, I create my submission node with the same thing. These are the attributes of the speaker nodes, the ID, the speaker name, and the biography. The attributes of my submission node is the title, the ID, the submission type, the abstract, the state, description, duration, date, start time, and end time. And if you notice here, in my submission, I'm not including the speaker itself because I have a speaker node. But in the submission, other attributes outside of the speaker itself. So now, I'm going to try to create a relationship between the speaker and the submission. So I'm going to say, given this speaker with this particular ID and the submission with this particular ID, now create a relationship between the speaker and the submission. So speaker S presented this particular submission, right? This is basically what this is doing here. Speaker S presented this particular submission. So your relationship, you could name your relationship anything. You could say probably submitted or something. But yeah, it's up to you how you want to name your relationship. Then I'm also going to create a document node. A document node is what I would use my, what I would create my vector index based off, right? So I'm just going to come here and just say, yeah, this is a submission for 2024 PyData conference. This submission is, title of this submission is filling, I'll just put the submission title, the abstract, the description, the submission type, the location, the date, start time and end time. And the speaker for the submission, for this particular submission type is put in the speaker name as well as the biography of the speaker. Then I'm just going to create this submission, this document node here. And I'm also going to create another relationship between the document and the submission. So I'm going to say this document mentions this particular submission, right? And yeah, I'll run this as well, create the relationship between the document node and the submission node. And yeah, this was done twice. It should be removed. Yeah. Then I'm also going to create, even as much as you can create a relationship between two different nodes, you can create relationships within the same nodes as well. So for the submission node, I'm going to be creating various relationships. So I have this submission A, submission B. Now I want to create a relationship between them. What is the relationship between them? I'm going to relate them based off of their location. So for example, all the submissions happening in the minories, right? They are going to be related somehow based off of the location. Then also all the submissions where the talk or tutorial is happening on the same day, I'm going to relate them together as well. So this is what I'm going to do here. Match submission 1, given the particular ID, and I'm going to get submission 2 as well. Then where the location are equal to one another, right? And I'm not going to say submission 1 relates to submission 2 based on location. So this makes it easy if I say I want to query, I want to get all the submissions, say all the submissions happening at minories, right? It makes it very easy to just get all the submissions easily and fast. Then the other one I mentioned also was creating a relationship based off of the date. So on date, I'm also going to create relate submissions based off of the type as well. So there are various types of talks, like there is a tutorial and there's a talk, right, for this conference. So I'm going to relate all, okay, yeah, question.
It feels like it's circular, this process, because you have to understand the doctrine and structure to get the graph.
Sorry, please, I didn't get that. The microphone.
So classic RAG is that you chunk documents, you insert some math, get some embeddings, and you can ask questions about this document I've never read.
Yes.
But this process you're describing, you have to understand the structure of to generate the graph.
Yeah.
So it's circular. I have to understand what I want to ask questions about to construct the graph to build my RAG. It doesn't go anywhere. I have to understand something about this subject matter.
Okay. Yeah, we are still getting there, right?
Yeah, but you're constructing the graph.
Okay. Yeah, I'm constructing the graph.
The point is you have to understand documentation that I want to understand.
Yes. So, like I mentioned, we are still going to get there, right? Especially when we scrape. I mentioned we are going to scrape the data from.
Let me understand my point.
Okay.
The point is you have to construct to understand some relation data. The subject, the document you have to understand the internal structure of the documentation.
Yes.
So they construct the graph.
Yes. To construct the knowledge graph itself, you have to understand. Okay.
That means I have to know what this document is. Classically, I don't care about it. I just ask questions and get answers about the RAG.
Yes, definitely.
But I have to understand, so I have to know something about the doc.
Well, yes and no. For this purpose of what we are doing, you have to know what the document, because we are pulling it from the API. But also, I mentioned that we are going to scrape the website. Now, we don't know how to represent that in the knowledge graph, right? But we are going to do that also here, because we are going to represent that in the knowledge graph without having to do this kind of query or kind of structuring the knowledge graph in itself. We are just going to use an LLM to create the knowledge graph directly for us in this case. So basically, it's just the same way. You don't have to know anything about the document. You just get the document from somewhere, put it into your graph database, then it automatically generates the knowledge graph for you. But in this case now, we are just still manually generating it ourselves because this is like an API JSON structure. I'm just trying to just let us just follow with just normal graph database, how it works. Then we can now start going into the full detailed RAG part of it. Yeah. I don't know if that answers the question. All right. So we'll still get into it, yeah. So now let's start working with the notebook. Let me just pull that up. And yeah. Yeah. I believe this is large enough. So we are importing some stuff. The config, LangChain, from LangChain experimental, we are importing the LangChain graph transformer. And back to what your question said, if you have a particular document, is the LangChain graph transformer that is going to help us convert it directly into a knowledge graph. So, and we are going to import a Neo4j graph, then chat OpenAI. So we initialize our LLM, and we initialize the LLM transformer. Okay, yeah, I've not imported this. And now, yeah, this is just some utility function to display the results in Markdown. Then we initialize our graph. We pass in the URL, the password, and the username. And we'll define some utility function, basically, to help us visualize our graph within this code. And now, we just want to load the data that we've already put in all the stuff we've already talked about in the way we are structuring our knowledge graph. We want to load that directly now into our graph database and just show the result. So yeah, this is running. And now we can see our graph database. And if you zoom in on your end, you'll be able to see, yeah, all the various relationships. And as a matter of fact, I can just copy this query and run it on the and yeah, we can be able to see the various relationships here as well. So I can zoom this, and we can see how all of them are related. The document node, the person, the speaker, and we can see various relationships here. So now let's go back to this. So now we are using the Neo4j vector store, and we want to create, we are using the OpenAI embeddings, text embedding 3 small. And now we want to create an embedding based on the document that we've put in based off of the document node, right? I want to just create an embedding of that and index it in the vector index, right? So what we are going to do now, we are going to do from Neo4j, you install the Neo4j vector store. Then from existing graph, we are just going to put the node label, that's the document, and the text node property. What we want to embed here is the text property of the node label. And we are just going to call the embedding function on that. And we are just going to give the name of the index document embedding. And we are going to run this. And this is going to generate our embeddings for us. And once this is done, this is making API calls to OpenAI at the moment. Once this is done, we can run this to see our embedding, our vector indexes here. And we can see, yeah, all the properties of the vector indexes at the moment that we have. And now we can refresh the schema here. So one of the first things we want to do, outside of using RAG for graph database, is you can do something called graph cipher QA chain. Basically, what this means is, based off of your knowledge graph, you can you feed the information of the structure of your knowledge graph to the LLM, and you ask a question to the LLM. You ask a question, then the LLM is going to take your question and the structure of your knowledge graph, then generate a cipher query. Then you run that cipher query against your graph database, and then return the result. Then the LLM picks the result and then returns it back to you in like a human readable format. So to just show this example, we ask how many submissions are there in total. Please group this in, okay.
Yeah, just quick curious, is there any restrictions on what models you can use for this? Does it have to know about GraphCipher?
At the moment, the models you could use, GPT-4o and Mistral. Those are the ones that are actually kind of powerful with cipher queries at the moment.
But are there other models that understand Cypher, or is it just that they're very good at it?
Other models understand cipher, but those two models are very good at it. Yeah.
Cheers, thanks.
Yeah. So once I run this, yeah, it's running the cipher chain. And now you could see the query that it's running. Match submission S, then return submission type as type, then count S. And it's telling me now that there are a total of 65 submissions with 16 tutorials and 49 talks. And I could ask another question and say, what are the various locations where the conference is holding? Then, yeah, it says, this is the cipher query here. Match S, submission, return distinct X dot location, right? And it says the conference is holding at Warwick, Minories, Salisbury, and Beaumont, right? And that's just without having to use any RAG-based system. We are not even using the vector indexes yet. This is just cipher to text to cipher, basically, cipher query. And now we want to use our vector indexes now. And we are just going to create a retrieval QA, right? So what this does, just to explain again, is it's going to take I'm going to put in a query now, where and when is the talk about graph database holding? Who is the speaker, right? So what it does is going to take this query that I have, run it against my vector, my embedding model, convert it to vectors, then use that to search the vector database, and then going to return the result, relevant document to the LLM, and the LLM then is now going to use that to generate an answer. So if I run this now, I'm going to get a result, running the retrieval QA chain, and this is making a request. So it says, the talk about graph database, titled graph database and retrieval-augmented generation, is scheduled to be held at the Minories on this from 13:30 to 15 o'clock. The speaker for this tutorial is Kehinde Ogunyale, right? So you could ask it other questions as well. So one other thing we want to do here is, say for example, there are some questions that I could just use cipher QA, right, to text to cipher to answer, and there are other questions I could use just my vector embeddings also, like the retrieval QA to answer. One thing I can do is I can create an agent, right, that combines both the text to cipher and the retrieval QA chain that utilizes the vector database as well. So this is what we are going to do here. From LangChain, we are going to import the agent executor, and we are going to create a React chain, and we are going to import the tools as well. Import runnables with message history, because we want to use Neo4j also to store our message history. What is this? Okay. Then now to create my tools, I'm just going to use put them in a list. Tool.from function. I'm going to give it the name, and I'm going to create a description for the tool, right? So basically, what this agent is doing is, I would say, for example, use this tool when you need to answer questions that can be answered directly, querying the database without having to use the knowledge of vector embeddings. The question will be a string, return a string. That's for the cipher chain. So what the agent is doing is, based off of these descriptions that I've given it, it's going to decide, the LLM is going to decide, do I need to use a cipher chain or do I need to use the vector embeddings? And at some point, it might decide to use the two. For example, if it goes to the cipher chain, does not find any results, it can decide to go to the retrieval chain also as well. Then for the natural QA chain, it says for answering text-based questions that are not easy or straightforward to answer, use Cypher queries, but can be using Cypher queries, but can be answered using vector embeddings. The question will be a string, also return a string. So we are also going to create a memory for the agent, and then we are just going to tie everything up together and just create our chat agent here. So I would run this. Then my question now to the chat agent will be, I am a software engineer, and I would like to learn more about graph databases and retrieval-augmented generation. Which talk should I attend? And then I'm just going to run this. Now executing the Cypher chain. Oh, apparently it didn't return any question, any result. Okay. I think it's still running. So yeah, let's give it a while. So basically, I'm making a call to OpenAI at this point, so I don't know why this is taking time. Still running. Okay, yeah, so as not to waste time, you can just try to run this on your own. Okay, so it's providing me, okay, saying something like, if you provide me with a schedule or the list of this. But yeah, we'll get back to it later, and you can just try to run it on your own and you get the result. So now let's go back to loading more data, right? So now we want to get more information about PyData conference itself. So one thing we can do is we are going to scrape the PyData job website, the PyData website. We are going to scrape the home page, the about page, and the job board, the Humbles page, and the sponsors board also as well, to just get more information about PyData there. Then now there is this library, open source library I'm using to scrape this called Gina Reader. And it's going to return the results in like a markdown readable format for you that large language models can understand, right? So now I'm just going to, once I scrape this data, I'm going to now put it inside a document. This is a document class for the LangChain users. I'm going to put the content of the script information into this page content, and I'm going to put metadata as the title and the URL, and just generate an ID of the content based off an MD5 hash, and use that as an ID based off the content that we've scraped. Then I'm just going to then start doing the classic RAG here. We are going to split each document. We are going to chunk it, because like I mentioned earlier, like there's a limit to what you can embed with all these open source embedding that we all these embedding models that we have there. So for example, if you have a document of 30,000 tokens, your embedding will most likely crash. It will not even just tokenize that or embed that for you. So you have to chunk it. So the chunk size that you want to use, or your chunk overlap, is just as a result of the type of data that you have and how you basically want to just approach it. So now I'm taking my chunk size to be 1024, and I'm using the token splitter from LangChain, and I'm going to split my document. So what I'm doing here now is scraping and splitting my document all at once. So so that I won't just take time in running the entire stuff, I'd run some of this before, and this is like the example of what the script document looks like. And after you've chunked it, this is what the document looks like here. Then the next thing we want to do is now, I commented this out because I'd run before. and it's going to take a while to run this particular one. You now want to use your LLM transformer, like I mentioned earlier. You use your LLM transformer to convert these documents that are already chunked into graph documents. Basically, what it's going to do is it's going to use OpenAI models to now start creating a knowledge graph for you. So it's going to start doing stuff like named entity recognition, start extracting various information from the text, from that raw document you just processed in, and just extract entities from it, extract relationships. How does this person in this document relate to another stuff, right? And just build that particular knowledge graph for you. So once you run this, you're going to get your graph document. And I had already run this, and these are the results. Like, this is the graph document that I get. You could see it broke it down into various nodes, saying this is a particular node here. It's saying this node is PSF, type organization. There's another node, PyLadies Global Council, organization. Then there's another node, person, called Matt Crooks. Then another node here, BBC named organization. Then it's going to start relating all of them together. And if you scroll down here, you're going to start seeing relationships, right? Relationships, source node, Bloomberg type, target node, diamond, sponsorship level. You start seeing how everything plays around one another. So now I'm just going to try to load this graph document. I already saved the pickled file already. Then I'm just going to run this pickled file and just run this. I'm just going to try to now put it into my graph database already. So I wrote something. The Neo4j graph that LangChain has does not have a functionality that I'm looking for, which is once I have the graph document, instead of having to reindex the entire thing, I just want to index the new documents that are there, and not having to like run embeddings on the entire thing. So I had to write a new modified Neo4j graph just to extend that functionality. And this file also is in the code as well. So, so I just extended that functionality from Neo4j graph, and I just created a modified Neo4j graph. So now I just added this function, add graph document with embeddings. So passing the embedding function. So what you're just going to do is embed these new documents that I have, and just then store it into my Neo4j graph database. Then this is just, I'm running this now. Then this is just a function to create a chat agent, since I'm just going to be calling it over and over again. Then now, there's, for this, all I just need to do is, I need to create a vector index here, like still with the same name embeddings. This is without retrieval. This is without the retrieval query, right? And I'm just going to explain something later about the retrieval query. Retrieval query is basically what supercharges the graph RAG in itself. Without the retrieval query, this is just more like, pretty much standard, like the normal RAG itself, and just does a few things. But there's also problem when it comes with the retrieval query as well. And why you cannot just use graph RAGs for everything in itself. So, we've built this now, and just want to ask a question, like from this QA chain that we built here now. Who are the keynote speakers, right? We don't have the keynote speakers from those stuff that we've pulled out. There's no information that specifically says, from the API, there's no information that specifically says, these people are the keynote speakers. But from the website, when we've pulled out information, like on the front page, we know who the keynote speakers are. And when we run this, we are going to see this result from OpenAI. It says, sorry, I lost my mouse here. So just a moment. Uh-oh. Just a moment. So, but yeah, we can see who the keynote speakers here are. The keynote speakers for 2024 PyData conference are Talia Allard, and you can see the title of the talk, the biography, and Dr. Rebecca Bilbro, and you can see the biography also. So my laptop is stuck, just a moment. Okay. Just a moment, I need to restart my machine. It's stuck. But yeah, we can just use this period to take any questions if there are any questions. Okay, yeah, please.
Thanks for the presentation. I was wondering, is there any way of a more systematic way of evaluating the graph RAG? I mean, for instance, yeah, we can build this and then try some questions, see the answers, and kind of get whether it's wrong or right. Is there a more formalized, more systematic way to evaluate how we can improve the RAG, maybe change the embeddings, maybe change the graph and see an improvement in the metric?
Yeah, that's a very good question. And that even boils down to the same thing as using normal RAG systems as well, right? How do you evaluate these systems? But there's this library, and there are some tools that LangChain have already built also using Langsmith. And there's this library called Ragas, where you could use that, incorporate that into your system. You have some set of questions that you know that you generate your data set basically. You have some set of questions that you know that these are the right answers to the question. And then you have some then you have your model generates like the answers to those kind of questions to you. Then you can now run use Ragas to now evaluate the entire stuff. How faithful is this this RAG system that I've just built? How consistent is it? How truthful is it? Right? There are various evaluation metrics that you could actually use to measure how well your RAG is performing. Yeah, and that can also guide you to know, okay, do I need to tweak my embedding model? Do I need to change my embedding model? Do I need to engineer my prompt rightly? Something like that. Yeah.
First of all, can I say really interesting presentation. Again, I learned quite a bit there. Thank you very much for that. My question actually is probably a bit more generic. One of the things that knowledge graph does, especially when you use it in this context, is explainability.
Yes.
Right. I wondered if that was one of the motivations for doing this. Is it also partly to try to explain what's been inferred by the LLM? Is that essentially, or is that one of the main motivators of this?
Yeah, that's one of the ways you could use knowledge graphs also as well, because you could get the results and you could actually even just get the graph of how most of them are related to see, okay, this is getting this answer from somewhere. Where is it getting the answers from? Like how are you drawing the relationship between this, and it's going to give you that kind of result. Yeah, and that also ties to when you're evaluating as well, like I mentioned. If you're evaluating the RAG system, how does everything tie together? How faithful is my RAG system in answering these questions? And when you use knowledge graphs like this, you could be able to see, okay, yeah, this is how this is kind of getting this kind of answers, and you can just play around it with the graph. Yeah.
Thank you. Just one more question.
Yeah.
The second thing I wanted to ask you was earlier, I think the gentleman had indicated that you were handcrafting the knowledge graph.
Yeah.
And somehow that there could be some sort of circularity in terms of what's been inferred. Am I right in saying that the knowledge graph, when used in this context, is kind of domain specific? So initially you do have to craft out the schema, but then once it's live and then you start feeding the data, as you demonstrated, you then take the data that's coming in and then somehow almost update the graph with the new data and thus keep the original schema of the graph. Is that correct?
Nope. So you could.
Please correct me.
No, yeah, sure. You could, like what I mentioned earlier, the reason why I'm crafting that at the moment is because I just wanted us, instead of just diving into graph database, graph RAG itself, just see how we could actually construct a knowledge graph from the scratch, right? So you could do this information that we scrape from the website. It could be a standalone on its own, right? Without any existing knowledge graph, and just build your knowledge graph from the scratch and just attach it to it. It could be a standalone thing. It doesn't have to you have to do this first before the other. It could be a standalone thing. I just wanted to show you could build your knowledge graph from the scratch, and also you could also like build your knowledge graph with just raw text that you have as well.
Okay, thank you. Cheers, thank you.
Yeah.
Good work.
Okay. Yeah, just to add my 2 cents on that debate over there. Like it's not really circular, right? Because you need to have like some subject matter experts building your graph, or at least evaluating it. So handcrafting the graph database shouldn't be really like an issue.
Yeah.
You need experts, right, to evaluate the graph anyways.
Yes, you need expert to evaluate the graph, yes.
Yeah, so 2 questions. Am I right in understanding that the nodes in your graph database are directly related to the vectors of the documents, or is there any connection between them, or are they completely separate entities?
Okay, so yes and no. So, like for example, the speaker node is not in any way my vector database, my vector index rather. The submission node is not in any way my vector index. But the document node, the attribute in the document node called the text, is what we index in the vector database. Yes.
Okay, good. Just the second question is just to see if I understood what you said in the previous questions towards the end. So the schema for the nodes that are created using an LLM is just a completely new schema that the LLM comes up with?
Yes, it's a completely new schema that it comes up with. Just basically named entity recognition, extracts entities from the text, and just tries to build relationship based off of that.
Yeah, okay, good, thank you.
Do you have any advice on scaling? Because LangChain is terrible at scaling.
Oh, yes.
So, do you have any other implementation we could do, or in your experience?
Oh, well, you could use Llama Index. I prefer using Llama Index for production stuff, yeah. But since this is just like a demo, yeah, you could just use LangChain, yeah.
Could you explain a bit more in detail how the knowledge graph is actually incorporated during the retrieval, or then also by the language model? Like, is knowledge graph just added to the vector database, and then it's just retrieved alongside the other documents and then fed to the language model, or how does that work?
Okay, yeah, that's a very good question. So before my laptop froze, I was showing something about QA retrieval without a retrieval query, right? And I liken that to be just like a normal RAG system, right? But now, one thing you could do, and if you remember my slides previously, one thing we are just adding to the graph database is actually more context. Why we are using graph database is to find relationship and add more context to the LLM to answer that. So if you are going to do that, there is this, I think it's just better to show you that. So, just a moment. So we created this like vector index before, yeah. This is the one I mentioned without retrieval query that you just use, yeah, it's just almost synonymous to normal RAG. But this is another one here. This one is with retrieval query. And this is the retrieval query here, right? Let me just move this. So what this does now is when the LLM uses the vector index to get answers, and when a user asks questions, you embed the text, right? And then you use that to fetch data from your relevant data from your vector database, right? And once you've gotten those relevant information from your vector database, what this query now does is now going to start finding other relationships from that particular node you've gotten from your vector database. How does this node then relate to other entities in my graph model? Then use that to fetch and get more context to send to the LLM. No. I wrote this query actually. Yeah. So you can write your retrieval query. So this retrieval query is very generic. It does not depend on the structure of what the graph database is at the moment. And there are some that are very like specific about what you want to generate. Yeah. So this just traverses the graph 2 level deep, basically.
And then what it gets back from Neo4j, is that just added to the context?
Exactly, yes. So for example, if you're asking a question about how the 20th century relates with the 19th century, the knowledge graph has that information. You are just probably picking something from that particular, when your vector database returns something, it just returns probably a chunk of information for you. But now you can just get more detailed information and more relationship with the retrieval query, add that as context to the LLM, and just generate more factual answers. I think we could just start taking questions now. Yeah.
You want to take?
No, you can start asking questions, yeah.
How does the context of this 1970s versus 1990s or whatsoever it was, how is it picked up in the knowledge graph?
Sorry, just a moment. Someone is asking a question here.
How is that, how are we sure it's in the knowledge graph in the end? Isn't it the same limitation that we presented at the very beginning?
Okay, let me start up my my Neo4j so that I'll be able to show you, because I don't think we saw the knowledge graph that was generated after we scraped the data. Yeah, so I think let me just do that. Let's just start up. Let me start Docker. Okay, my Neo4j is up and running. I can just copy this. Chrome. Okay, restore pages. So now I'm connected here, right? So now if I want to see what happened in the previous ones, let me just look for the query here after writing it. So now we have other various entities here. Let me just expand this query to say maybe just show me 2,000 nodes or something, so we can have a full picture. So these are other nodes that are created, like something like activity. Let me just click on the document node and start seeing various relationships from there, how all of them are related with one another. You could see initially when we had our first knowledge graph, we had just the speaker node and the submission node and the document node. But now we have other stuff like activity, benefit, community, concept, date, email, organization, person. And this is just built from, let me just even click on person, and we can start seeing this. This is built from the LLM itself using the graph transformer, right, to get all the various entities based off of that text that we've just imputed into the system.
So it's using vector.
So these relationships are built thanks to how close in our vector database these different chunks you build are?
So we did not use the vector database in generating this relationship at all. We use the LLM graph transformer. So just a normal raw text, then we pass it to the LLM graph transformer. All it does is generate entities, generate nodes, generate relationships, and then link all of them together to form a knowledge graph. That's basically what it does. Then afterwards, then we now index it, index the document node into into the vector index itself. So that's basically, the knowledge graph is generated by the LLM graph transformer. Yeah. Does that answer the question?
I think it does.
Yeah, thank you.
Thanks a lot for the talk. So if I understand correctly, initially, like
there's like different use cases, right? Like you have, if you already have some information that lends itself to a knowledge graph, you can just build that manually yourself.
Yes.
And allow an agent to also query that to get extra information
Exactly.
alongside your documents. Your documents might even be in like Quadrant.
Exactly.
You can get extra information from this knowledge graph. That's one thing.
Yeah, that's one thing, yes.
And then the other thing is you just have a bunch of PDFs, and you wanna also, you don't wanna just do like blind embedding search. You wanna actually like be a bit more intelligent about the relationships between those documents, in which case you might use the LLM transformer, which like generates you a graph just from, so you just have a folder of PDFs, you run that through this, it generates you a graph which you upload to Neo4j, and now that same thing, like with the different tools, can use the documents embeddings from there and also the relationships from there.
Exactly. So once you have your relationship, your retrieval query, you could, like I mentioned, this one is just generic. It doesn't depend on the type of node that is there or the relationship that exists. But you could even write a more specific one if you know how your knowledge graph is connected. But for this one, I don't know how the LLM graph transformer is going to return the nodes to me. So I just wrote a more generic one that just traverses the graph 2 level deep, right, to get more additional context for me, and then just send it to the LLM. Yeah.
So out of just a bunch of PDFs, instead of getting just the embeddings and putting them next, and the chunks and putting them next to each other in the context and sending it to the LLM, we get that, we do that, and then because we've already embedded these chunks into this knowledge graph, we can also see what's nearby.
Exactly.
And add that into the context.
Exactly.
So that's like the value add.
Yes, exactly.
Being able to like not just in embedding space, but in like actual relationships between stuff space.
Exactly.
Add stuff next to your context.
Yeah, yeah. So to give more light to that, shed more light to that, for example, you could even create your knowledge graph in a another unique way where you have the initial document itself before you chunk it as a node, right? And then you have all the chunks pointing back to the initial document, right? So for example, if I have something like, just permit the use of this example I'm using, something in the 20th century, how we relate to the 17th century, right? Maybe when you are chunking, it cuts off at a particular place, right? And it's in one document. And the other one, it's the other part of the information is in another document chunk, right? But if you are just using normal rags, you might just pick only the first one that is just related to that. But you've lost context of the other information in the other document, right? But with this graph rag and the retrieval query that you've written, you'll be able to now see the relationship with the other documents that you have. Then now add the other documents that are relevant as context to that. Then you now have like a full-blown context for what you want to send to the graph, to the LLM. Yeah.
Hey, nice talk, super exciting. I was just wondering, maybe you touched on this at the beginning, but did you end up deploying this kind of system in production and like have some users using that?
I have not deployed this to production yet. Graph rags is something still fairly new because it was discovered by Microsoft pioneered it like this very early this year. Yeah, so it's still something very new out there. Yeah.
Okay. And can you anticipate some kind of like just broadly top of mind the kind of problems you would encounter if you were to deploy this?
Scalability with knowledge graph is a problem. Yeah, because maintaining your knowledge graph, yeah. So like I said earlier, it's not where you just apply in every situation, right? It has to be for unique and specific cases. Because there are still some ways you could get your ordinary rag to perform way better. Yeah, so it's just, yeah, how you, the problem that you are looking to solve with that, yes.
Thank you.
Very last question.
Okay.
Hi, yeah, thanks for that talk, it was fascinating. Just a quick question. Obviously this is really just for, in this example, just for text data, right?
Mm-hmm.
There's a lot of work on sort of solutions.
Sorry, I didn't get that.
There's a lot of work on deep learning solutions for like image data, like earlier today there was a multimodal talk, right?
Mm-hmm.
Is there any space or are there examples of using this sort of graph database approach with non-text data, non-text concepts?
Oh, yes, I think you can use that. Number one, it depends on how you structure your knowledge graph, right? And since most of this multimodal stuff also, it also has to deal with your, like the way you embed your image or your videos or something like that. And Neo4j, for example, now has like a vector vector database. You can use it as a vector database in itself. So it depends on how you actually structure your knowledge graph. How you say, okay, this image is from, you tie the relationship to a particular document or something like that. Then it just depends on how you structure your knowledge graph. You can use it pretty much for multimodal stuff. Yeah. I can't just probably run through all the code again because I have to restart my kernel and just run. I'll just probably talk through the majority part of the code and just, yeah, see through what we need to do. So I was discussing about this earlier, the vector index retrieval query. But also, as much as graph LLM is very, very good, at least in generating more context, there's also a downside to it, right? So for example, you might be providing too much context for the LLM, right? And now you are spending a lot of money on tokens because it's not cheap to send all this stuff to OpenAI or whatever large language model you're using. So there probably has to be like some way to tweak your graph RAG to be able to like optimize for cost also as well. And there are actually some points where you might even not be able to send the stuff to the large language model because you've provided way too much context for it, right? So there are just ways to handle some of these things. And if you look at what I try to mimic, like just create a typical scenario of that. I ran this, put a limit of 25 here, and try to send my results, which speakers are software engineers, right? And I just get a rate limit error. Because now, even though I'm getting information from my vector index, it's traversing the graph 2 levels deep, and I'm putting I'm just overblowing with a lot of context. It can't get most of the information I'm giving it already. So it's going to come up with a rate limit error and stuff like that. So those are kind of like the limitations also around it. You have to, when you are building your graph RAG, it has to be like, you have to tie it to your specific use case, right? And know, okay, what kind of, how many levels deep do I need to traverse my graph? And what kind of information do I want to return as well? Because you could actually specify everything in your retrieval query. You could write your retrieval query to specify exactly what you need, or the amount of information you need, or other kind of things, right? The number of attributes that you need from the knowledge graph as well. So you could do a lot of things with your retrieval query. The retrieval query here, I think, is the meat of this graph LLM, because aside from your vector index, you can get the node, and just the node that you've gotten from your vector index, you can now just use that to now say, okay, let me see what other things that are related to this node, and just get more context based off of that. And yeah, you can still also tie the same thing to put everything together into an agent using your QA, your text to cipher model as well, and you can use your retrieval QA chain as well to just tie everything together, make it an agent, and yeah, it works.
Yeah. So if the LLM is producing the schema from the document,
yes.
Presumably there's going to be a lot of stuff in there you don't need. So would you go through and prune it?
Yeah, you could. Okay. Yeah, you could go through to prune it.
The subset of things that are actually useful and eliminate everything else.
Yeah, you could do that. Yes, exactly. Yeah. You just need to write proper cipher queries to just look through the entire stuff, just go through it. Just because of this demo, we could not just look into everything at once. But yeah, it's advisable for you to just look through what the LLM has provided for you, the knowledge graph that it has given to you, then just try to now prune it and see how you can even make it more better. Yeah. because there are some entities that you might see that might be labeled wrongly, or some relationships that might not be actually correct. So you can just try to tune it. Yeah.
Thank you.
So just a moment. I would just like to use this opportunity to just promote my newsletter as well. You can subscribe to my newsletter. And sorry, let me just share that. You can subscribe to my newsletter. I provide educative and insightful content on my newsletter as well. Yeah, so thank you. Thank you very much. Oh, it's not showing.